Okay, a piecewise function you probably have never seen before. It's probably new to you for Algebra 2, which is fine because it's in an Algebra 2 textbook, so you should be good to go. Piecewise functions, when we think about piecewise, we see that word piece. So it's two or more functions that have been pieced together. So we will only be looking at portions of each function. If you follow the process that I'm getting ready to explain to you, this should not be a difficult lesson. All right? If you follow the process that I'm getting ready to explain to you, should not be a difficult process. You need to make sure you are using a pencil for this lesson, because you're going to have to erase. No, you're just going to have to erase something. All right, so the first thing says f of x equals 3x plus 2, x less than or equal to negative 2, negative 4, x greater than negative 2. So this looks a little funky. All this really means, okay, is that you have two equations. Here's your first one. Here's your second one. We're going to forget about this for right now. Okay, so we're going to kind of put that off to the side. What does f of x really mean? Y. Right? So this is really y equals, we're going to put the first equation in our box. So y equals 3x plus 2. That's the first equation that they gave me. And then just for right now, I'm going to put that inequality piece. X is less than or equal to negative 2. That's the one that goes with that. But we're just going to put it there and let it hang out for a minute. Okay, then the next one says y equals negative 4. Do you guys see that? There's no x with that, but that's okay. And then that one said x is greater than 2. Negative 2, thank you. All right, so let's draw an x and a y axis. Now let's go back to our algebra days. Let's graph the blue line first, the y equals negative 4. What kind of a line is that? You guys remember? Is it straight up and down, or is it horizontal? Good, it's a horizontal line. If it was x equals something, that would be a vertical line. But remember, y equals just this horizontal line at negative 4. Okay, so at negative 4, I'm just going to draw a horizontal line. At negative 4. So I went down to negative 4, and I drew a horizontal line. Okay, do you guys remember how to graph the line that's red? What do we need in this? Now it's like so easy that it's hard, but this is y equals mx plus b, so what do we need to graph this? B and m. The b value is 2, and m is 3 over 1. You guys remembering this? Okay. It's like so easy that we forget how to do it because we've done so many other hard things. Okay. So here we go. So we're going to go up 2 on the y-axis, and then up 3 and over 1. Isn't that the same thing as going down 3 and back 1? Okay. So I have my line. Let's go ahead and you can use the edge of your binder if you want to make a straight line, or you can use a ruler later.
Does it really matter if it's like straight?
I mean, I'd like it as straight as possible, but if your OCD is kicking in, that's fine too. If you don't have OCD, great. You are blessed. Okay, so this part is not new to you, right? We could say that this part is kind of, yeah, we remember this. This is the part now that is new. I have these conditions over here. I have x is less than or equal to negative 2, and I have x is greater than 2. This is where piecewise comes into play. We only want pieces of these two lines. So the first thing to do is to draw a boundary at whatever number they gave me. So they gave me x is less than negative 2. So that's where my boundary is going to be at. At negative 2, when x is negative 2, there's a boundary. So either with your pencil or a highlighter, we're going to draw a dotted line that's a boundary at negative 2. So you see my green negative 2 line? Yes, I can. Can you see that purple? Okay. Now again, don't get frustrated because this is the first time you've seen it, so just take a deep breath. Let's look over here what it says for y is equal to -4. The blue one's going to be easiest for us to start with. It says, I want everything where x is greater than -2. So everyone needs to watch up here. I want everything where x is greater than -2. So if I'm looking at this blue line, at -2 right here, see where I'm drawing that purple dot? At -2, everything that's greater than that is to the right or to the left. Which one? To the right. Everything over here is what's greater, right? Everything over this direction. So that's the part of the line that I want to keep, which means I'm going to erase everything on the other side. Okay, do you see how that happened? I erased what was on the other side because that is not greater than -2. Now, is there an equal sign underneath the greater than sign? No. So that means, do you guys remember when you were shading inequalities and you had an open circle or a closed circle? Okay, if there's no equal sign, is it open or closed? Open. It's open. So that means that I need this circle to be an open circle at -2. Now let's look at the red equation. According to the red equation, I want everything that is what? Less than -2. So if I am on this line, the part of the line, if you want to, it might be helpful for some of you to see where I'm drawing this orange line. It might be helpful for you to put your pencil there and say, okay, which side is less than? Less than -2 is to the left, correct? So that means that's the only part of the red line that I want is what is to the left. So that means I'm going to erase this whole big line up here. Okay, just stay with me. This is the first time you've seen it. It's okay. Stay with me. So because the qualification said I only want what is less than -2 for the red line, less than or equal to, that means I had to remove everything else that was on that side. Now, is there an equal sign underneath this inequality? Yes. So that means there is, right? Less than or equal to -2. So that means I want a closed circle for my red line. And I'm going to draw that circle on -2. The circles are always on the boundary line. This would be finished. Okay, this is a finished problem. We have pieces of two lines that satisfy this equation. It is weird, and it's uncomfortable because it's new. And inequalities are always students' strong points. Kind of. Okay, we're not finished. Okay, let's look at example 2. So we're going to chill out. You guys think that everything in Algebra 2 you should already know. You don't. Welcome to Algebra 2. Right? It's my job to teach you these things. Otherwise, I would be out of a job.
We wouldn't be here right now.
That's right. Okay, so follow the same process. Split your two equations up, right? They give it to you in two equations. So the first one, 2x minus 1. You can write your boundaries down, but you don't have to worry about graphing them right now. The first thing to do is to put your x and y axis on there. We're going to graph both of these with an M and a B, right? The M for the red line. Let's graph the red line first together so we can all make sure we're on the same page. So my B value is -1. That means that's where I'm starting. And then from there I go up 2 and over 1. Right? That's my slope, up 2 and over 1. Down 2 and back 1. Up 2 over 1, up 2 over 1. Please make sure that your line spreads the entire distance. Would anyone like a ruler? What? No, you don't have to. I just do it because it's easier for you guys to follow. Anybody else want a ruler?
I do.
Have some messages. Or Austin. Who needs one? Anybody else want a ruler? Okay, let's graph the second one now. So our M is -1/2. Our B is 3. If you want to use a highlighter for your boundary line, sometimes that's helpful. You may use a highlighter for the boundary line. You can come grab one of mine if you need to. Up 3, down 1, and over 2. Except you're not going to be able to, it's going to bleed through.
I'll do it that way.
It's still going to bleed through. Okay, everyone have their graphs graphed? Graphs graphed. What do we do next? Someone remind me what we do next. The boundary line, okay? And my boundary is at x equals 2. Oh, you can kind of see that. And if you take it one at a time, you should do okay. So if we look at the red line first, it says I want everything that is greater than 2. Greater than 2 is which direction? To the right or to the left? To the right. So that is the part that I want to keep on my red line, is the part that is greater than or equal to 2. So my red line means I'm going to erase this. And then do I want a solid circle or an open circle for my red line? Is there an equal sign? Yes, so you want a solid for your red line. Okay, now the blue line says I want everything that is less than 2. Which direction is less than 2? To the left. So that's what I want to keep. So I'm going to erase what is to the right. Now for my blue line, do I want an open circle or a closed circle?
Open.
Open because there's no equal sign. Notice that on example 1 and example 2, the lines are going on opposite sides of the boundary. Do you guys see that? They're shooting off to opposite sides. That should always happen. They should be going opposite sides of that boundary line. They should not be on the same line, same side. Okay? Questions on example 2?
Yep.
Yeah.
So where would y'all draw circles?
So on the line, x equals 2, on our orange dotted line, that's our boundary line. Do you see on the red equation, there's an equal sign? Do you see what I'm talking about? It's greater than or equal to, so if it's equal, it's a closed circle. So the red line gets a closed circle.
You just draw them wherever you'd like to draw them.
The circles?
Yeah.
The circles you draw wherever the line, see how my red line hits the orange boundary line at this point right here? I just circled it in black. Where it hits it. Wherever the red line hits your boundary, that's where the circle should be.
My graph doesn't look like your graph.
Okay, I can help you with that in just a minute. So let's try example 3. Okay, separate them out. Example 3.
I don't even know where you do this line.
How do you find the boundary?
So, of 3.
Don't ask me.
So this is
Is he-
your y intercept. This number out here is always the y intercept. So it's on the y-axis.
I do. I got 10 hours. I'm just tired.
Okay. We haven't seen an x squared plus 1. I mean, we have before, but for this example, we haven't seen x squared plus 1. Don't panic, Anthony. It's going to be just fine.
I wasn't paying attention. I forgot about it.
Oh, I thought you said, oh, I know. And we have y equals 3. What's the easy one to graph on this example? Okay, do that. And then I'll help you with the other one. Okay, we've already talked about, first of all, what's the shape of an x squared graph? It's a parabola, right? So now we're going back to chapter 2. Is this parabola going to open up or down? Up, because it's positive. Now, think about what we just did with our absolute value. What happened to the graph when there was a number out here on the end? Do you guys remember?
Vertical.
Say that again, Justin.
Vertical shift.
A vertical shift. Do you guys remember that when there was a number out on the end? So this is the same thing. There's a vertical shift of positive 1. Make yourself a note because you have one like this in your homework and it's not a 1, it's a different number. Vertical shift of positive 1. All that means is you're going to take your parabola
Move it up one.
and go up 1. So instead of starting it at 0, you're starting it at 1.
It's magic.
Okay, so instead of starting it at 0, you're just starting it at 1. See if you can do the shading correctly. Okay, so you have your 2 lines graphed, or your 2 graphs graphed. 2 equations graphed.
You say shade it?
No, did I say shade it?
Yes.
I'm sorry, I didn't mean shade it. See if you can erase and figure it out correctly. Draw your boundary line.
I forget how you find that.
Okay, so where's our boundary at, Anthony? Your boundary is here.
Okay.
So at -1 is where you're going to draw your boundary line. The blue line is probably going to be easiest to figure out, right? I want everything that's greater than -1 for my blue line. So which side is greater than -1? That's the side you want to keep. Patrick, is the blue line going to have an open circle or a closed circle?
Close.
Excellent, because there's an equal sign, right? Now my parabola says I want everything that is what? Less than -1. So Chelsea, which side did you erase? Did you erase the right side or the left side of the parabola?
The left side.
You erased the left side? Okay. So if it says they want everything less than 1, isn't less this direction? So that's the side that I want to keep. Okay, so this side is the one that I want to keep. So I'm going to erase this part of my parabola, because I just want to keep the side that is less than -1. Does the parabola have an open circle or a closed circle, Austin?
Open.
Open. Why?
Because it doesn't have the equal sign.
Excellent. All right, any questions? Your problems are you have 4 of these to do in your homework, only 4. And you may write on both, listen, on 3-5, they are both labeled 3-5, one's absolute value and one's piecewise. You may write on both of those assignments because they're graphing, so you may write on them. I will go get those off the copier. Let's take a break till 2:20.